This case study explains a biometric system design based on the iris signature to classify 40 subjects. 30 subjects taken from standard database like Cassia version 1 and 10 subjects are taken from self-created database. The system states are explained from the image acquired from the database, and the second stage, which represent the feature extraction. Here we consider the Fourier descriptor, and the third stage, it is the machine vector creation or template database building. And finally, the final stage, which is the classification. It contains 3 neural networks classification methods using backpropagation, probabilistic, and radial basis function, and the 4th classifiers, which depends on the distance measurement. It is called Euclidean distance.
Welcome everybody in the 2019 Second International Symposium on Advanced Intelligent Informatics. My paper is Optimization Techniques of Iris Signature for Better Performance. I am Prof. Musanna Hamd from Computer Engineering Department at Mustansireh University, Baghdad. First, I will demonstrate the unimodal biometric system which is proposed for this research. It is based on the iris traits to identify 40 subjects as a genuine or imposter. This system contains many components. The first component is the Fourier descriptors, which is a feature extraction method to find the iris signature in the frequency domain. The second component is the classifiers. This system contains 4 classifiers. Actually, they are comparative classifiers to find the best recognition rate among them. They are the backpropagation, the radial basis function, the probabilistic, and finally the Euclidean distance. The first 3 classifiers represent neural network models. The third component is the database. Our database containing 2 types. The first 30 subjects are taken from Cassia database, and the other 10 subjects are taken from real iris. Our methodology depends on the applied Dogman's rule for iris pupil segmentation and normalization. Then we apply the 4 comparative classifiers to find out the recognition rate accuracy, where we use 1 image for testing purpose and 3 images for training. After that, we try to enhance the system performance by optimizing the machine vector length, which keeps the accuracy at maximum rate. This slide is a block diagram which explains the biometric system based iris recognition. Here we have 2 images, one of them taken from Cassia database and the other is taken from real iris. The features of the 2 irises can be extracted and represented as an iris signature in frequency domain. After that, we found that maximum rate could be obtained when the machine vector length is 150 values. Actually, we can optimize the performance by applying 2 methods. Depending on the iris signature, there is a region where the enrichment data can be represented. These enrichment regions are distributed in the most right and left of the iris graph. So there are 2 techniques which can be applied to optimize the machine vector length at minimum value and keep or maintaining the accuracy at maximum rate. The 2 techniques are sequential techniques and standard deviation techniques. In this slide, The primary result of the accuracy of our proposed system shows that backpropagation and Euclidean distance satisfied the maximum accuracy rate at 96.67 that belongs to the Cassia database, while the real iris satisfied 100% because the high resolution of iris images. So we proposed two techniques to find or to maintain the maximum accuracy rate at lowest machine vector values. The first technique selects sequentially new vector values and find the system accuracy according to these new values, while the second one depends on the standard deviation formula to find the maximum standard deviation of the new vector values from the enriched region.
This figure is a graph for the extracted features in the frequency domain. We can clearly notice the symmetric in the data, and this is definitely one of the Fourier transform property. Our question is, this machine vector can be optimized. That means some of redundant data can be excluded. This
table shows the recognition rate of the 10 subjects taken from real iris. The result shows that the backpropagation and the Euclidean distance and the probabilistic advances all other classifiers by satisfying the maximum accuracy rate at lowest machine vector values. The recognition rate of 30 subjects taken from Cassia database show that the backpropagation and the probabilistic satisfied maximum accuracy rate at lowest machine vector value. Also, we note that the standard deviation technique advances the sequential technique by satisfying the maximum accuracy rate at lowest machine vector values. The last table represents the recognition time comparison for the four classifiers. From the table, we show that the probabilistic takes the minimum runtime for 150 machine vector values, which is just 2.5 seconds, and for a machine vector of 20 values, the probabilistic takes just 0.488 seconds. Finally, we can conclude that if Fourier descriptor is applied as a feature extraction, we can optimize the iris signature to satisfy maximum accuracy rate with minimum machine vector values. Among four classifiers, the probabilistic and the backpropagation satisfied acceptance results. Thank you very much.